My name is Duncan Shaw. The paper concerning which I will be speaking is called On the Cause or Causes of Inertia. And in a sense, it is tied to a paper that I will be speaking on tomorrow, which is called On the Structure of Atoms. The first paper concerning inertia is related to an aspect of a broader picture, which I will expand upon tomorrow. I have no slides to present, so everything I present today will be by word of mouth. I will ask you all to keep your powers of visualization in your heads open, because you will need that power. Now, the paper itself, the abstract reads, the article sets out two possible causes of inertia. The first is that a subatomic substance, ether, restricts the movement of atoms and atomic matter. And the second is that vibrations within atoms restrict the movement of atoms and atomic matter. What is inertia? Here I refer to the treatise of Kelvin and Tate entitled Principles of Mechanics and Dynamics. They say matter has an innate power of resisting external influences, so that every body, as far as it can, remains at rest or moves uniformly in a straight line. The inertia of matter is proportional to the quantity of matter in the body, and it follows that some cause is requisite to determine a body's uniformity of motion or to change its direction from the natural rectilineal path. The subject of inertia, as I think we all know, has perplexed scientists for many centuries, and it may continue to perplex scientists as we move on. In any event, this particular paper presents two possible causes. They're quite separate. The first being the existence of ether. And to put it quite simply, if ether exists and surrounds matter, in other words, surrounds atoms, and someone tries to push something that is made of atoms, it comes up against the resistance of the surrounding ether. That's theory number one, and it's quite simple. I will expand on it. The other is quite different, and it relates to the concept that inertia is an innate property of matter. Well, the other feeds into that concept, but it relates to vibrations. The vibrations being within the atomic structure. And the suggestion here is that the vibrations within the atomic structure themselves form a limitation on the movement of matter. That may seem strange, but I will expand on it, and whether I will convince you or convince myself, I don't know. This paper is basically set up as a subject of discussion. I do not profess that what is in this paper is necessarily the right answer. And I think we all agree that we're dealing with things that we cannot see, and we're using our human brains as best we can to try to deduce what is causing the various phenomena with which we are all quite familiar. The two approaches are articulated, I think, quite well by Amitabha Ghosh, who said, "Is the inertia of an object an intrinsic property of matter, irrespective of the presence of other matter in the universe, or is it nothing but the manifestation of the interaction of the moving object with other matter present in the rest of the universe?" You can see the split, which is quite, in my view, quite clear. I do address a little later on which concept may be correct or might both be correct. However, first step is the ether approach. The ether approach is built upon the basic premise that there is a finite, substantial type of matter that is called ether. And it permeates everything. We've heard much about it this morning or this afternoon. Well, the idea here is that it permeates every atom, every aspect of the universe. In a sense, this idea flows from a couple of papers that I have had published in regard to gravity. One is called The Cause of Gravity, a Concept, and the other is Flowing Ether, a Concept. Those two papers operate on the proposition that ether and what we generally consider matter to be, in effect, atomic matter, interact, and that the laws of motion, Newton's laws of motion, apply to those interactions. Everything that I put in this paper and will be in the paper that I present tomorrow is based upon the proposition that there is a physical, tangible basis for absolutely everything that occurs. That's a premise on which all my work is based. It may be a right premise, it may be a wrong premise, but that's the premise upon which my work is totally based. Now, this approach, the ether approach, is much like Mach's principle, which ties all movement in the universe to everything that exists in the universe. As Amitabha Ghosh said, Mach's principle proposes that the inertia of an object to acceleration is due to the resistance generated by its interaction with the matter present in the rest of the universe. One can see that concept, that even what is at the far reaches of the universe, if there are far reaches of the universe, we do not know, but that absolutely everything plays on everything else. But for all practical purposes, this approach, the ether approach, really comes down to the ether that is right next to the atomic matter that it interacts with. And when atomic matter is pushed and pushes against the ether, the idea here is that that ether presents, in effect, a kind of friction which limits the push and which requires some energetic effort to cause matter to move. Now, and I note here, and I'm not suggesting this is a new theory by any manner of means, but it's a theory that seems to me to make some sense. And I note in the article in references 6 and 7 that there are at least a couple of recent articles in physics essays that are based upon this approach to inertia. Now I move on to the vibrations approach. I start with the proposition that it is an undisputed fact that atoms vibrate. And the proposition is purely and simply that the vibrations of the parts that make up an atom cause atoms to resist being pushed. Now, how could that be so? Well, now, here it goes to the second paragraph under this particular heading, and I shall read it. It is well known that rotating or spinning objects, such as flywheels and gyros, resist being moved off their planes of rotation. This observation is equally applicable to pendulums that oscillate back and forth. A good example is the Foucault pendulum. It maintains its plane of oscillation while the Earth rotates beneath it. It stands to reason that vibrating objects must have the same property. As stated by Eric Lathwaite, and I quote, "An oscillating mass has all the properties of a wheel and mathematically may be so represented. In all these situations, there are back and forth oscillations of matter, each having its own plane of oscillation. The common factor that ties planes of oscillation to the observed resistance to movement. The center of a body's inertia depends upon the movements and the masses of each individual part of the body." Here I go back to the Thompson and Tate work that I quoted from earlier, where they say the kinetic energy of any system is equal to the sum of the kinetic energies of a mass equal to the sum of the masses of the system, moving with a velocity equal to that of its center of inertia, and of the motions of the separate parts relatively to the center of inertia. They add this: the moment of inertia about any axis is therefore found by summing the products of the masses of all the particles, each into the square of the distance from the axis. The argument here is that when a force moves an object, the movement changes the planes of vibration of virtually all the atoms that comprise the object. And in my suggestion that it stands to reason that the collective vibrations of the object's atoms provide the object with a measure of resistance to movement. This resistance, I suggest, is innate to atomic matter. I next make reference to Thompson and Tate's treatise. It deals extensively with gyrostats, and their observations go on for many, many pages. There are all kinds of mathematical equations that are brought into the picture. I am not equipped to follow those mathematical equations. I wish I was. But this particular area of their work, which basically is an analysis of gyrostats attached to frameworks and the movement of the framework, is, in my view, a virtual treasure trove of information that can be derived from just that simple experiment. Because if atomic material material comprised of atoms has vibrations. Those vibrations are probably in every conceivable direction. So that if there is a push on a material object, each one of those planes will be changed, partially changed. There will be set-offs, because some will be in one direction, some will be in another direction. There will be a whole variety of planes. But one push, and they are all changed. And it seems to me that if that is the case, then there must be an element, not a major element, but an element of resistance to the change. And if anybody wants to follow this idea up further, I would be absolutely delighted if they happen to have the mathematics to follow all this work by Thomson and Tate to see just how much or whether that work bears on this particular approach to inertia. What I'm getting at here is based upon atoms having structure, based upon that structure being subject to vibrations. But if one looks to vibrations, one might wish to look to spin or rotation within the atomic structure, or vortices within the atomic structure. These are ideas that are commonly held by many scientists. Why do I choose vibrations rather than spin or rotation or vortices? I do so for a reason, that in my view, and this will come out tomorrow, atoms must have structure. If atoms are to be able to form solids, they must be able to hang together. Very difficult to hang together if you think of the electrons, for example, being in orbit. How do atoms hang on together if the outer part of the atom is a cloud of electrons? If they are in orbit, how do they attach to each other? How do they form solids? If they're in orbit, this is the outer part. This is not the nucleus, but the part of atoms that join up with other atoms to make solids. So I revert to vibrations, because in an ordinary structure, a building, a bridge, there are vibrations. They're natural to any solid structure. But you bring in orbits and spins and vortices and ask yourself, how does that fit with the necessity of structure to make a solid? In all common sense, and I'm trying to revert to common sense here, they don't fit. But what does fit is that an ordinary structure vibrates. And so I use the vibration aspect. Lathwaite, for example, was thinking of spinning wheels. But he also looked at the oscillation aspect. And it's the oscillation that is implicit in a vibration that I look to here, and that's why I made reference to Lathwaite. Now, conclusions. These are two separate ideas. Each suggests a method of limiting the movement or resisting the movement of an object, which is right. or might they both be right? And the conclusion I come to, and it's simply an idea that could well be disagreed with, is that the more likely method is the vibrations method that is innate to matter. It seems to me that it should naturally be more powerful than the other. And so I think of it as the more likely candidate to be the dominant method or rationale for inertia. I think that presents what I would like to present on this, and I am open to questions. Yes?
Of course, you would expect me to say something, maybe the paper also,
Yes.
the nation of Inertia.
Yeah.
I tried to download this paper much earlier. I couldn't. Glad to see it here now, black and white. The idea of aether or ether is a very attractive word. A medium which fills the whole of space uniformly. The only thing that can fill the whole of space uniformly is nothing. If you have something, it cannot have an infinity.
You speak louder, please.
And the only thing that can fill the whole of space uniformly is nothing. So the idea of ether is so attractive, I think it's difficult to accept. I can accept the vibrational aspect also of inertia. That if the vibrations in the atom would align themselves in such a way as to produce a force in the direction of acceleration, then inertia could result from that vibrational aspect. Is feasible, it's acceptable.
I missed the last bit of what you just said.
The vibrational aspect.
Yes.
If the vibration would align themselves to be in the direction of acceleration, then we have a force which could explain the cause of inertia. In other words, I found it difficult to accept the aether aspect, but the vibrational aspect is possible, especially when you look at what happened to gyroscope and other things, that there's a likelihood that the vibrational aspect of the relation to the force of inertia is a possibility, and I can accept it. I can accept that. It results in a field which restricts the increase in motion or decrease in motion of a body. This is a lot of food for thought. This
Oh, thank you.
I like it.
Thank you. That's what it's intended to
Yes.
be, food for thought. Yes, sir.
Does ether have mass, or is there a quantum of ether? Is there a unit of ether?
I conceive of ether as being particulate, real. And
It does have mass?
If you are using the word mass in the sense of real, then I think of it as real. And if you're thinking of it in terms of it having mass in the sense of certain innate qualities, I think of it that way too. I conceive ether to be comprised of ether cells, flexible cells that have elasticity. In other words, they are a form of matter. That's the base upon which I'm working.
There's another answer to this question. I think somebody, Glenn Borkert, and this is one of the things we talk about in our group, in our Hacking the Universe, is that the universe there's no such thing, this is Glenn Borkert's work with neomechanics, there's no such thing as a partless part. And in fact, in our group, and talking about this is fascinating stuff you're talking about here, Duncan, is that it was funny to see my dad come to a conclusion that Glenn had already talked about, and that there's an ether too. That is, you can't have any mass, anything, you can't go down and find the ultimate mass. Everything is going to be made of something else. And that in fact, we are already in our group, when we were looking at atoms, seeing that it's really hard to make a mechanical world of the universe without already not only thinking of ether, but ether too, because if ether is being held together as a particle, it has to be held together in some way. And one of the things that about the talk that's interesting about vibrations is I start to get the same feeling of, okay, that is a very interesting model, but what keeps things together? One of the things we're always looking at are atomic structures. This is one of the things I think this hackathon is going to start looking at. We talk about bonds. For something to vibrate, we have to have it so that it comes back and forth. One of the things you were saying, Musa, is, well, there's got to be something else there. You can't just, again, I go back to the galaxy. It doesn't matter what we're talking about, even if it's just ether itself. If you don't have something there for something, the vibration's interesting, but how does that, why doesn't just keep going? Why is it coming back? What makes a bond? What makes things stick together? And that's one of the mechanical models. And what our world is in this Glenn Borkert really world, and our hackathon world, is that there's infinity, meaning you'll never have an ether that's non-divisible. It's going to be made up of infinitely small things all the way down, continuously. We have to eventually, of course, pick a level to which we look at it. We only have mass and motion. So the thing is I like the idea of vibrations, interesting, but how come it's not just flying out? You come in, what keeps it coming out? We can't give it magical bonds in our world.
That's the subject of my paper tomorrow.
Good.
So maybe I should postpone that till tomorrow. But
okay, that's fine.
One thing about what you just said, taken from Glenn Borchert's work, is his view that there is no end to going downwards in the existence of particles,
Yeah.
because there are always smaller ones going to infinity. I have great respect for Glenn and his work. That is one aspect of his work with which I cannot agree.
I did a paper on that, and I want to put this into your head so you think about it, okay? Because we get this a lot, and I actually did a paper and a presentation on this.
Mm-hmm.
If you assume there's an ultimate particle in the universe, I imagine myself as this thought experiment that I can get smaller and smaller and smaller. So we've arrived at the ultimate particle. Now I'm going to make that particle bigger and bigger. So it's now a planet in front of me. It's huge. I will continue to shrink myself down as far as I want. According to an ultimate particle, I won't be able to find a hole in it, because a hole is going to require it to have a part. Now, that means this is again my thought experiment. I'm not saying I'm right or wrong, but this has convinced me that he's right, is that if you have that circumstance, what you really have is an infinitely dense particle, because you can't have parts. It's a part without parts. It's not what he says. He says that you can't have a partless part. So, in my conclusion, even mathematically and logically, if you believe there's an ultimate particle, you have to logically conclude that ultimate particle is infinitely dense. If it's infinitely dense, it's infinitely heavy. And then you get into the problem of, okay, now what do we do, kind of thing. The same thing as Musa was saying, if you're looking at certain things with infinity mathematically, well, you have to accept that it's either You got to sort of punt.
It's all
So,
ten universe.
so what I don't, that's what thing I want to put into your brain and have you think, if you have a rebuttal, that's fine. I'm not saying that it isn't possible. But in my mind, that's the thing that sort of got me to the point that said, I can't accept infinitely dense particles. I can't. So that was my logic on that. But I agree, it is debatable still, but that's my logic.
Well, fair enough, and you feed totally into what I've got to say tomorrow.
Okay, great.
And because amongst other things,
Sure.
tomorrow, the proposition that I put, again, subject to this, that we're dealing with the ultimately small, and we can't see it.
Sure.
So how can we be certain?
Sure.
And I shared an idea. I'm not certain, but I've come up with ideas.
Okay.
And those ideas are not in accordance with Glenn Borchart's idea on that particular point.
Sure.
And you say there can't be anything that is ultimately massive, or I forget the word you used.
No, infinitely dense, meaning.
Infinitely dense.
Yeah.
That is so. And I take the opposite view. I say you can. And it's how those things hook together. That is the key. And I would prefer them to carry on discussion along this line.
Sure.
When we get there tomorrow.
Absolutely, great, I'm looking forward to it, thank you.
If there's time, I want to make one comment.
Yes.
There was a comment as to what the density of ether might be if ether existed. And I'm not just talking about photons that are not ether. I don't regard the photon as an ether. But there have been people like Tesla and Lloyd Kelvin who have speculated as to the actual density of ether, and I have myself that it's about 10 to the minus 20 kilograms per cubic meter. But if the idea of ether having mass, or having density, I should say, bothers one, they might think about this, that if I fire a bullet so fast that it goes out into outer space with a near its escape velocity, we have the situation where the kinetic energy of the bullet, due to so-called gravity, the kinetic energy of the bullet gradually disappears and becomes nearly zero kinetic energy. Then the question arises, where did that kinetic energy go to? And it seems to me, and probably others, that kinetic energy lost by the bullet becomes adds energy to the ether, or at least contributes energy to the ether. Otherwise, you have the mystery of kinetic energy disappearing. And when you say it's no mystery, the kinetic energy lost became the potential energy gained, the gravitational potential energy gained. That sounds intellectually brilliant. But what does it really mean to say the gravity has gained the potential energy lost by the bullet? Well, I allege that unless you consider ether to have mechanical properties, and one of them density, that to say that gravitation potential energy is gained really does not have any meaning. It's one of these terrible circumstances that a scientist by the name of Linder talked about, where words, if used correctly in sentences, seem to make sense, but really don't.
I agree.
I might add that Einstein, in a 1930 speech, he recognized this problem with his own theories, and he said, we all as human beings used to regard mass as a primary quality, but now it seems like mass is a secondary property and space is a primary property, because space in some cases is eating matter up. Well, so Einstein took his approach, which I roughly call the bending of space mathematically. But he recognized that this was, not an easy thing to accept, and would have a lot of reasonable doubters. In fact, he said in that speech that a lot of people think what I'm doing is downright silly. Well, anyway, I'm a little more comfortable with allowing ether to have mechanical properties, including density.
I think one of the things is that Dr. Carazani, my mentor, who got me all into this, I agree with you completely, and I think a lot of people in this room, Duncan's same concern, is Carazani said something very profound. He says, when you look at these, look at kinetic energy, you have a velocity there, but you don't take into account how that happened. And what Carazani, it's very much in the same what you're saying. We shoot something up and we talk about it, the kinetic energy, now potential energy. No, we're interested in the system. We don't care what you call it. We have something was moving, now it's not moving, something is happening, something is changing. And this is the same way with fields. We talk about them, we don't give them physical characteristics. Carazani says we apply kinetic energy. Oh, yeah, look what he says. We apply kinetic energy equations to decay. Decay has no outside force coming in, yet we'd apply it. It's all over physics, where we have things we're talking about, things we're looking at, where we don't look at the entire system. Oh, something's moving. We don't talk about how that's moving. When Carazani found the mistake in special relativity and said, you're using two frames, that's an physical and an impossibility, because in space there's only 3 dimensions. You can't have 2 frames. There's no such thing as that. When he reduced it, he came up with the equation that, this is the same thing you're saying, Carl. He says, to move something, mass has to get smaller. So if we're standing right here and there's something sitting here, a rocket, it's not going to move on its own. We can't just talk about, now let's say it has velocity. That's not satisfying. Something caused that velocity. What Carazani says is when you take away the mix, this is just the same view of the same thing. You take away the extra frame, you look at the equations that you now have, which are similar to special relativity but aren't the same. You now explain what a rocket is. If you have a rocket, what are you doing? You're expelling mass out one side to push it the other way. You have a complete system. And what we don't have in physics constantly are things talking about things that don't give us this complete system. They don't give us a mechanical model of it. We talk about bonds in the middle, things staying together. I mean, I continually go back to the galaxy. We talk about galaxies. Why do stars stay together? We have this, I was talking to my dad about that. We have this this intuition when we see swirling things that we see in nature, that they're staying together. But we all know Newton's laws. Every star in the galaxy should just go fly out. What keeps it there? What keeps atoms together? What keeps these structures together? You can't just say they're magical bonds, so it's an electric charge. I get tired of that. That's not satisfying to me anymore.
In fact, by my view and what I know, that most of physics is, in fact, from the Newton, who told that inertia, in fact is something, and that by his equation he will describe by acceleration this something which he don't know from what it emerged. But and so it is, I think, in all 300 years that the physicists, in fact, knew that the real world, what we are describing, is the change of density, of real density, and we describe this real world by a kinematical equation, by the ratio of length and time, and by the velocity. So, as you say, many times it is forgotten, but many physicists at least intuitively knew that with this equation they are describing the real world. You can find also in Einstein's general theory of relativity place. I can find exactly the page where he says that in fact his equation described the real world, and he says, let's return to real world. This is really an article, a paragraph there, and he then continue with the equation of continuity. So he starts and he continues with the equation of continuity, and he starts to calculate the pressure, and from this equation of quantity, he came to Maxwell equation, which is in fact his he follows in fact the Maxwell equation in his equation of general relativity, or it is based the tensors in general relativity is in fact parallel to the tensor in electrodynamic, tensor of electromagnetic field. It is similar, and Einstein took, in fact, this tensor to his equation. So this is the thing that at least intuitively most physicists understand that by their equation, by the motion, that if we see that something is going with some velocity, so you see, we can describe it this way, that if some car is approaching us with some velocity 5 kilometers per hour, we don't feel very great danger. If another car is approaching us with 100 kilometers, we feel great danger. But the real physical actions is not in the velocity. The real physical actions are in the pressure when the car hits to our body. That's the physical reality. We describe this physical reality. In fact, we describe inertial forces by this velocity. If we see that the car is going 100 kilometers, not the velocity is the reason of the real mechanical thing. What will happen when the car has a velocity 100